Ever pondered about the origins of the universe and how everything we know came to be? It's a thought that can truly boggle the mind, isn't it? The universe, with its vast expanse of galaxies, stars, and celestial bodies, is a marvel of grandeur and mystery. It's like an infinite cosmic ballet, where celestial bodies pirouette in the grand dance of existence. Now let's journey back, far beyond recorded history, to a time when everything we see, know, and can't even fathom was compressed into a space smaller than an atomic particle. Yes, you heard it right, smaller than an atom. It's a concept that feels almost impossible to grasp, isn't it? Picture this. Imagine a tiny dot, smaller than the period at the end of this sentence. Now imagine that dot containing all the matter of the vast cosmos. It's like trying to fit all the water on Earth into a single drop, or like squeezing all the air in our atmosphere into a tiny bubble. That's how unfathomably dense and infinitesimally small the universe was at its inception. This notion, as abstract as it might seem, is what numerous scientific theories and observations suggest. The universe in its initial state was not the sprawling cosmic ocean we see today. Instead, it was an inconceivably tiny point, a singularity where the normal laws of physics as we know them ceased to apply. With this thought, we embark on a journey of exploration and understanding, a voyage across the cosmic seas of time and space. We delve into the heart of existence itself, into the very fabric of reality. We stare into the face of the infinite, and it stares back, challenging us to comprehend its monumental scale and its minuscule beginnings. Imagine, everything you see around and beyond once existed in a space tinier than an atom. So how did this minuscule point evolve into the vast universe we know today? Well, it all starts with a theory you might have heard of, the Big Bang. The Big Bang isn't an explosion like the name might suggest, but rather a rapid expansion. Think of it as the universe stretching out from a state of almost unimaginable density. Around 13.8 billion years ago, everything that now makes up the cosmos was compacted into a space smaller than an atomic particle. Then, in less than a blink of an eye, the universe started to expand. This expansion happened faster than the speed of light. Yes, you heard it right, faster than light. It's a concept that challenges our everyday understanding of how things work. But then again, we're talking about the birth of the universe here. It's like baking a loaf of raisin bread. As the dough rises, the raisins move away from each other, but not because they're moving on their own. It's the dough expanding that creates the distance. After the initial rapid expansion or inflation, the universe continued to grow, but at a slower rate. For a long time, the universe was a hot, dense soup of particles. It took about 370,000 years for the universe to cool down enough for the first atoms to form. These atoms then grouped together to form stars and galaxies, and voila, the universe as we know it started to take shape. But here's the kicker. The universe is still expanding, that's right. The galaxies are moving away from each other as we speak. And recent observations suggest that this expansion is not slowing down, but accelerating. So there you have it. From a speck smaller than an atom, we've come to a universe that's still expanding and evolving. Mind-boggling, isn't it? But how can we compare the universe to an atomic particle? Aren't they vastly different in size and nature? I hear you ask. Well, let's dive into this. To comprehend the early universe's state, scientists often turn to atomic particles as a reference point. This might come as a surprise since, on the surface, atoms and the universe seem like polar opposites. But when you delve deeper, you'll find striking parallels between the two. Think about this. Both the universe and atomic particles are fundamentally composed of energy. Energy in its various forms is the building block of everything we know. Atoms, with their buzzing electrons and nucleus, are tiny packets of energy. Similarly, the universe, although incomprehensibly vast, is essentially a grand cosmic energy field. In the initial moments after the Big Bang, the universe was incredibly hot and dense, much like the core of an atom. It was so compressed that it was actually smaller than a subatomic particle. Yes, you heard that right. The entire universe was once smaller than an atom. Just as atoms are not static, the universe too is in a constant state of flux. Atoms vibrate and move, their electrons leaping from one energy level to another. Similarly, the universe is always changing, always evolving. Stars are born, they live, and they die. Galaxies collide and merge, the universe expands, and just as atomic particles follow certain physical laws, so does the universe. The laws of physics that govern the behavior of atoms are the same laws that rule the cosmos. This interconnectedness provides a beautiful symmetry to our understanding of the universe. So when we talk about the universe being smaller than an atomic particle, we are not making a literal size comparison. Instead, we are exploring a concept that goes beyond physical dimensions. In essence, the universe and an atom are not as dissimilar as they seem. They both represent a world of possibilities. Now that we've journeyed from the atomic to the universal, what does this all mean for us? Well, it offers us a new perspective, a fresh way of looking at our existence and our place in the grand scheme of things. You see, by understanding that our universe began as something smaller than an atomic particle, we realize our own insignificance in the vast cosmos. But don't let that dishearten you. Instead, let it fuel your curiosity and your thirst for knowledge. It's a humbling thought, isn't it? Our entire existence, everything we know and love, is just a tiny part of a universe that began smaller than the smallest thing we know. But within this insignificance lies our true strength. The ability to comprehend, to explore, and to understand the mysteries of the universe. And that's just it. Our journey doesn't end here. Our understanding of the universe is ever evolving, ever changing. Each discovery, each revelation brings us one step closer to understanding the true nature of our universe. It's a never-ending process of learning and exploration, and that's the beauty of it. And don't forget, each one of us is a part of this magnificent universe. Every atom in our bodies was once a part of a star, a part of the universe. So in a way, by understanding the universe, we're also understanding ourselves. And here's something to ponder upon. If our universe began as something so small, what does that mean for other universes? Could there be other universes, each with their own laws of physics, their own realities? The possibilities are infinite. And that's what makes the study of the universe so fascinating. So let's keep exploring, keep questioning, keep learning, because the more we learn about our universe, the more we understand our place in it. And who knows, maybe one day we'll find the answers to the questions we've been asking since the dawn of civilization. We're but a tiny part of an ever-expanding universe, a universe that began smaller than the smallest thing we know. We've journeyed from the unimaginably small to the incomprehensibly big. But the journey doesn't stop here. As we stand on the precipice of knowledge, the beckoning of the cosmos is undeniable. It invites us, urges us to dive deeper into its mysteries, to lose ourselves in its grandeur, and to find ourselves again, transformed by wonder and awe. Imagine, if you will, the universe as a grand cosmic library filled with stories waiting to be read. Tales of cosmic collisions, of stars born and dying, of galaxies spinning in the vast dance of space-time. And we are but humble librarians tasked with the monumental duty of decoding these celestial narratives. But remember, the universe doesn't surrender its secrets easily. It demands the rigor of science, the patience of a scholar, and most importantly, the insatiable curiosity of a wide-eyed child. So let's continue this journey together. Let's ask the hard questions, challenge the known, and explore the unknown. The universe is a dialogue, and every one of us is a part of that conversation. So, let's engage. Let's be active participants in this cosmic discussion. Let's continue to learn, to explore, to discover, because every little piece of knowledge brings us one step closer to understanding our place in this grand cosmic scheme. Don't forget to like, comment, and share this video. Let's keep the conversation about our fascinating universe going.